Hi everyone. In this video I will show you how to create the G-code using the NX program. G-code is a widely used computer numerical control programming language. Its main use is in computer-aided manufacturing to control automated machine tools. First, hit the Start button and look for Siemens NX. Now click on drop-down menu in front of Siemens NX and find NX Manufacturing. The CAM component of NX allows the machining operations needed to cut out a specific solid model to be identified, and also to create the associated G-codes and machining documentations. All of these can be done within the NX environment without the need to port the part to a separate CAM program. Now click on New, and then from the environments select Model. So here we would first create the solid model in the model environment, and then we would use this manufacturing environment to define the machining operations and create the G-code. Here you can set the name, so I would change it to example. Now you can set the location where you want to save your file. Select this second desktop, and then click OK, click OK. Now you are in the modeling environment and you can select the datum plane first. So I would select this XY as my datum plane. Now I would select a rectangle tool, sketching tool. The dimension I would choose is 100, 150 for width and height respectively. Now click on Finish and extrude this sketch for 25 millimeters. Now close this dialog box, go to Sketch, select the top surface, click OK, click the rectangular sketching tool and start a rectangle inside the previous one with dimensions of 90 and 45 millimeters. Now I would select the midpoints to make sure that the inside rectangle is exactly in the middle. Now I would use the fillet sketching tool and fillet the corners for the inside rectangle. The radius for the fillet is 5 millimeters. Click on Finish. Now you can create a cutout using this recently drawn sketch. I would type 10 for the distance. I would reverse the direction and select Subtract. So the distance 15 is better. Now click Apply. So the cutout is created. You can hide these blue lines by right-click and hiding the blue lines. Now I would click on Sketch, select the top surface again, click OK, draw another rectangle here, somewhere between the two rectangles. Again, I would make sure that it is symmetric. Now click on Finish. And now I'm going to create some holes on the corners of the recently drawn rectangle. General hole, simple. Hole diameter is 20. I would select the corners of the rectangle. The depth is 15 millimeters and the diameter is 20. Click Apply and close the dialog box. Now we can hide this blue rectangle. Right click and hide it. So the model is ready. Now you can go ahead and click on File, click on New, and this time select Manufacturing Environment. Prismatic milling and hole making. If you want, you can put your initials here for the name. And here, make sure to set the location where you want to save your file. Click OK, OK. And here there are some differences that you can see between the modeling environment and this manufacturing environment. We have these 4 items here: Program Order View, Machine Tool View, Geometry View, and Machining Method View. And here we have Operation Navigator, Machining Feature Navigator, Machine Tool Navigator, and Manufacturing Compare Tool. Another difference between this environment, manufacturing environment, and that of modeling environment is that the coordinate system here is XM, YM, and ZM, and M stands for machining. So in order to create a G-code, you need to go to these 3 steps: creating a tool, creating geometry, creating operation. In this example, I'm going to create 3 different tools. So the first one would create this pocket here in the middle. The second one would mill and finish the surface on top. And the third tool that I'm going to create would create these holes in this solid body. So I would click on Create Tool. From the type, select Mill Planner. From the tool subtype, select the second one. And here, generic machine. For the name, type N underscore mill, and then OK. So here you can set the dimensions for your tool: 10 for diameter. For the length, I would choose 45 millimeters. For the flute length, I would type 25 millimeters, and flutes, 4 flutes for this tool. Here you can see the difference between 2 flute, 3 flute, and 4 flute cutting tool. So here, after adding this dimension and information for tool, I would continue with I would go ahead and select shank. So I would leave it as it is and go ahead with holder and set these dimensions here: 20 millimeters for lower diameter, 10 millimeters for length, and 20 millimeters for upper diameter. Click OK. If you go to Machine Tool View and highlight this end mill tool that I already created, you can see it here in the graphic window. So this tool is used to create this pocket inside this solid model. Now I'm going to create a second tool. So I will click on Create Tool. So again, Mill Planner for type. For tool subtype, the same as previous one, mill. and then for the name I would type face_milk. Click OK. Now you need to enter the dimensions for your tool. So for diameter of this tool, I'm gonna type 40 millimeters. For length, 45 millimeters. Or 10 millimeters for length, and for flute length, I would type 5 millimeters. And this is a 2-flute tool. So now I would go for shank, click on the define shank, and here set the dimensions. 10 millimeters for shank diameter, 45 millimeters for shank length, and 0 for shank taper length. Then click on holder, and here add the dimensions the same as previous one, 2, 10, 20, 10, and 20, and then click OK. Again, if I go to machine tool view and highlight the tool, you can see it in the graphic window. Now I'm going to create a third tool here. From the type, select hole making. From the tool subtype, select STD drill and change the name to drill, and click OK. Here again, you need to add dimensions. For diameter, type 15 millimeters. For point angle, 118 is good. Point length 0, corner radius 0, length, for length type 50 millimeters, and flute length type 35 and 2 flutes. Leave the shank as it is, and for holder, add information the same as the 2 previous tools. 20 millimeters for lower diameter, 10 millimeters for length, and upper diameter 20 millimeters. Taper angle 0. Click OK. Now that all the tools are created, it's time to add the workpiece and machining coordinate system. So here, if you go to geometry view, you can see MCS main machining coordinate system, and a workpiece must be added automatically under machining coordinate system. If you expand it, you can see it, and again under workpiece, another machining coordinate system is added. Now you can edit workpiece and the coordinate system for machining. First, let me edit the machining coordinate system. Make sure to move the coordinate system on a corner on top of the solid model. And for clearance, select plane, clearance options plane, and for the plane specify it as distance at distance. Select the face, click OK for this message, and here type 10 millimeters. Click OK. Now right click on workpiece and edit this part. Specify part and select the solid body. Click OK. Next, specify blank. Instead of geometry, select bounding block. And here for the coordinates, leave everything as it is, except z and plus, and change it to 5. Click OK. So notice that these 6 parameters here would define a bounding block that allows for the geometry of the finished part to expand within this enclosing box. So then click OK. And here you can set the material for finishing this solid body. I would leave it as it is. If you want, you can change it by clicking on this wrench. Then click OK. So we created all the tools, we created the geometry, and it's time to create the operation. So right click on Workpiece and then click on Insert, then on Operation. The type would be Mill Planner for the first operation. Then select the first subtype, which is floor facing without walls. For the tool, for this operation, so this one would be face milling. Click on face mill that you already created a tool for. Leave the geometry as Workpiece and method mill finish. And then here you can set the name. So you can leave it like it is, floor facing. Click OK. Now in this form you can add whatever information that you want this operation to have. Information like feed and speed, geometry, the solid body, and non-cutting moves, and tolerance and clearance, and so on. So here first you need to specify cut area floor. Click on this icon, select the top surface, click OK. Then for the cut pattern, select zigzag. For the percent of flat diameter, type 50%. For depth per cut, type 3, it means that when the milling machine wants to go to a lower level, it would go for 3 meters lower than the previous level. So type 3 for depth per cut. For feeds and speeds, set the spindle speed to 2000 round per meter, and once you type this 2000 here, if you click on this calculate feeds, it will calculate the other fees and rates for you. So you don't need to add manually. For strategy, change cut direction to conventional cut. Here for non-cutting moves, you have different options that you can set. So click OK. This operation is complete. You can see this sign here. This sign shows that the toolpath has not been generated yet, and this cross sign here shows that the toolpath is not verified yet. So it is time to create the toolpath. Now highlight the operation, then generate toolpath. Here you can see the toolpath is generated on top of the solid body. Now verify the toolpath. Click on verify. Here scroll down, and here you can play the operation for yourself. Click OK. Now notice that a check mark is placed here. Now I'm going to define a second operation to create this pocket inside the prismatic solid body. So highlight the workpiece, right click, insert operation. So the type is still mill planner. Select mill planner. For subtype, select pocket milling. For the tool, select end mill, geometry workpiece, and for method, select mill mill rough. You can set the name, but I would leave it like that. Once you click OK, a form will appear here that requires you to add information for this operation. Click OK, the form appears. The first thing you need to do is to specify cut area flow. Click on this item here, then select the bottom face of this cavity. Click OK. Percent of flat diameter, type 50%. Depth per cut 3 mm again. For feeds and speeds, change the spindle speed to 2000 round per meter and hit the calculate icon, and it would calculate the other feeds and rates for you. For strategy, select conventional cut. And then click OK. Again, you see these two signs. You need to create the toolpath first. Click on Generate Toolpath. Then verify the toolpath. And you see the toolpath is generated inside the cavity. If you verify the toolpath, this form appears here. You can play the toolpath for yourself. Click OK. Now I'm going to define another operation here, Workpiece insert operation. This time the type would be hole making. The subtype would be the first one. The second one, drilling. For the tool, I would select drill. Geometry is workpiece, method, drill method. You can set the name. I would leave it as it is. Click OK. And the form would appear here that you need to add information for this drilling operation. I would specify feature geometry. So then I would select all the 4 holes. Disregard this alert here. Select the other 3 holes. Now click OK. You can set other parameters here. So here we have all these 4 holes added into this list. Click OK. For feeds and speeds, again, for spindle speed, change it to 2000 round per meter. Hit the calculator. Then click OK. So this third operation is also created here. You need to define the toolpath. Disregard this warning here. Now verify the toolpath. Play the toolpath for yourself. And then click OK. Now if you right click on one of these operations, you can go to post process. Click on post process, click OK for this message. Now here select mill 3-axis. Then click OK. Click OK. Here is the G code for the first operation, which is shown here. you can see the G-code for the other two operations. Go to Process, Post-Process, 3-axis, and here the G-code for the second operation. And now for the third operation, right-click, Post-Process, Mill 3-axis, OK. And here's the G-code for the hole making process. So we have all these three operations which are verified. Now you can play each of these operations for yourself. So the G-code is ready. You can submit it through Moodle. And here is how you can create a G-code in the NX environment using the manufacturing CAM environment.